Uh, Hello, good evening all. So I am Debarati Chakrabarti, working as a lecturer at University of Hull. This work was done by one of my postgraduate student, Ravi Ranjan. He is the co-author of the of this article. Here we tried to address actually the problem of missing data imputation, especially in bankruptcy data for the challenge of regarding bankruptcy prediction and like most of the approaches that are available or most of the solutions that are available nowadays for data generation or data imputation, this is a non-deep approach or shallow learning approach. So instead of employing or deploying any deep learning models here, we try to encash the very basic machine learning or classical machine learning methods here, along with the merits or exploring the merits of granular computing. So that is what this work is all about, although it is in a very naive stage for the time being, and we are working on it for further improvement. Now, the question is, what is bankruptcy? Bankruptcy actually is the what is bankruptcy prediction and what is bankruptcy actually estimation of the likelihood of failure of a company. So when a company fails, we called it to be bankrupted, and the possibility when we are determining that what is the possibility of the company to be a failure, that is what is known to be bankruptcy prediction. Now, why we are working on this problem? And that is primarily because, as we could see, this is just some data that we have collected from the source of Statista. That is where it is being shown that different American companies, how actually x-axis is showing the assets in billion US dollars, what loss they have encountered around the years and what was the highest loss, and like that. This graph is simply reflecting that bankruptcy is a huge challenge nowadays to be addressed, to be the prediction of this kind of challenges actually. So it is very necessary nowadays. Now, what are the associated issues to the problem of bankruptcy prediction? First one is credit risk assessment, then fraud detection or supply chain finance, financial risk prediction, prediction of investment risk. So, since we know that in any company, those all the stakes are involved, especially the investors' interest, and investors don't need to be always a billionaire or millionaire, but we as common people could also invest to some companies, and we have to be assured that whatever assets we are investing there should not turn out to be a complete loss. Okay, so now there are different solutions. Since I am a person from the background of AI and I don't have the background of finance or economics, so I might not be very well aware of the domain knowledge, but as an AI scientist, I know there are certain issues, the challenges that are there to predict this particular to predict this bankruptcy in any company. Now, the data set, first and foremost problem that are associated with the data set. Whatever the data set that are available to design any model or train any model, here there are actually different missing entries. Now, corresponding to different features, actually here I have shown the the missing entries corresponding to the Polish bankruptcy dataset. It is actually openly available dataset, and it is available in UCI Machine Learning Archive. So there, what we have seen that there are 5 years of dataset actually available there, and the first and foremost challenge there is that there are thousands of missing entries. Now, with these missing entries, we can't train any model and can't ask the model to be very reliable. So we need to come up with a reliable prediction on those missing entries before using those data. Second challenge here is that highly imbalanced data set that is actually applicable for different challenges, different medical domain challenges and every other challenges where there is the data set that we are having there. The companies that faced bankruptcy are really less compared to those who have not faced a bankruptcy ever. So that is why whenever we are about to train a model, this data set is going to be highly imbalanced there. Okay. Second is we are mostly dealing with a high dimensional data set because there are different features which the domain experts found to used to find very interesting, and those features might not be always relevant, and considering all the features might lead to some misclassification as well if those are not much relevant. So those all are the challenges that we are dealing with and we are trying to address it. So what is the focus of this work? The focus of this work is, as I have already mentioned, that we are going to design a shallow learning model, not a deep learning one. And here we are trying to avoid training multiple models against different features because the existing solutions are mostly doing that. And we are also trying to avoid accessing the entire database since the database usually are large in size. So we are trying to avoid accessing the database again and again while predicting any missing entry. So if we have 10,000 missing entries in a certain database, we should not have to access the database 10,000 times to predict all those 10,000 missing entries. Okay. Now, how we have done it? We have tried to explore the merits of granular computing. Now I'm repeating the word granular computing. I Okay, let me introduce what granular computing is. Granules are actually being treated as a very basic of human cognition system. That is, we as human beings always try to granulate the things while recognizing something. Say this is a huge classroom or huge lecture theater. Now I may not focus on the entire lecture theater at the same time. We may focus on the individual rows, that could be granule. I may focus on individual attendees, that could be a granule, and I may focus on how they're looking or while they're paying attention. So those might be different granular levels. So in a bigger granule, we might be drawing some features, and based on those features, we might be treating some entities present there to perform the same. And accordingly, we are going to make our decision on that level instead of going through the very individual or data point level. Okay, so here why we are using that merit of granular computing and how we are using it. So here we are going to describe that, and we have also designed an AI-driven end-to-end pipeline for the task of bankruptcy prediction. So the first one is that we are raw input data should be fed to the model, and their missing data filling with granular semantics will be done. Then data standardization will work. Then feature selection, data balancing, classification, and finally prediction. So this is the proposed pipeline of the entire method. Okay. Now, as we have mentioned that it is going to be missing data filling with granular semantics, that is going to be the primary contribution of this particular work. So how we are doing it? Say we are having a data set that is phi, and it is a d-dimensional data set, small d-dimensional data sets, and characteristics. Say we are having n, capital N number of observations given with us. So the entire data points that we are now dealing with is going to be capital N cross D. Okay, so there could be numerical and categorical features. So we are first going to do here, we are going to convert the categorical values to numerical values. Then we are going to compute the feature semantics, and we are going to form contextual granules. Why these granules? We are claiming to be contextual because the granules are being formed considering the feature similarities and how semantical the features are. Now, then we are going to perform the granular imputation of the missing values. So, if this is our categorical features and it is having the cardinality of capital C, then this is how it should be converted following this equation. It should be converted to the numerical values. So FC bar here is representing the corresponding numerical values. Now, next step is we need to detect the missing entries that are present there in the data set. Normally in a data set, those are being denoted as NaN or a question mark. So we are here going to use a mask vector. Here that vector is going to be as is being represented as small k suffix j. So if it is null, that is the entry is null, then the mask vector value should be 0, otherwise 1. Okay, and this is how we are going to detect all the missing entries or missing elements that are present there in the database. Now, in while we are formulating the contextual granules, we have to keep it in mind that granules should preserve the entire context of the database. It should not miss it. So what we have done, we have here used Pearson correlation to measure the feature similarity and finding the closest set of features, delta number of small delta number of features to that missing element. Now please remember, small delta should be much less than D. D is the dimension of the database or the total number of features present there. Now say this X is a missing element and it is present at some location that is being represented as alpha beta. Now closest delta number of features should be found around beta. Closest eta number of observations, eta will again be much less than n, and it should be found around alpha. So the size of our granule is going to be delta by eta, assuming no missing values are there in that particular granule apart from X. Okay. Now it is just an example. See, this is our database. Now we have actually created a very small database out of the actual one, the original one, and there are so many missing entries. We could observe that. Okay. Now say we are going to predict this particular value. Now around these values, what we could see that there are 1, 2, 3, 4, 5, 6 features are there, and in total 9 observations are there. But as we have claimed that once we are about to form a granule, so the size of the granule should no more be 6 by 9, but it should be much less. Okay. Now we are then going to find the correlation between the features. Now, as we could see, the features are net profit, total liability, working capital, current assets, short-term securities, retained earnings, and etc. So these are the features that we have considered here now. And we are about to find out the feature correlation among different features. Now, please note here, if this is the missing value that we are going to predict, here the feature is total liability. So we need to find out the features, the closest features that are closest to total liability. So what are those features? Those features are current assets and working capital. Okay. So, so please note it down. So now we are going to form, this is the mathematical formulation of this granule, and delta number of closest features will be selected depending on the maximum values, the closest features, and rho is representing definitely the Pearson coefficients, and this delta number of features are getting selected given this condition. And eta closest observation will also be found out, assuring that there should be no missing entries in those observations present. So now, if you remember this figure from there, we are now going to form a 2 by 2 or a 3 cross 3 granule. Okay. Now, the closest features that we have found out from this correlation matrix are going to be working capital and current assets. Okay. And we should not consider this sixth observation because it is having a missing entry. No, we should not consider this third observation because it is having a missing entry here in this current asset. Okay. So, this is how now, this is how the granule will look like. That is, we have considered these two closest features, those two closest the closely correlated features and their according values. Now this is the missing entry that we are going to predict, and here we are going to use a linear regression. Okay, so a linear regression model, this is our contextual granule that has already been formed, and this is the example granule actually, but in reality the granules are going to be bigger. And this is how the granules will look like actually, with delta and eta number of delta number of features and eta number of observations. And then we are going to train our model based on that granule. So here here this will be treated, this means it is going to, here a linear regression model is going to get trained, and this is the parameter theta. So with respect to this particular granule, how it should be trained, this should be used as to be our input features. Okay. So this will be the input features, and these are going to be the corresponding labels. And this is going to be the query vector. So accordingly, this value will get predicted. So this is how the entire model is being trained. The prediction of missing values are being conducted here. Next is the remaining pipeline, how we have used it. Okay, how we have designed the entire pipeline, because we have described so far how we are going to predict the missing value in the granules. So the remaining parts, that are data standardization, then feature selection, data balancing, classification, and prediction, those are still left. Now data standardization is being carried out with unit variance and zero mean. Feature selection, we have here used random forest primarily. We may use some other techniques as well. Data balancing is done with SMOT model or SMOT. And classifier, we have used 6 different classifiers here, and we have also made a comparative study there that which classifier is working the best. And then the prediction. Now, these are the experimental outcomes on predicting missing values, and we have actually run it over 5 years, all the 5 years data, whatever available there in the police bankruptcy data set, and we have made the comparative study with 3 different benchmark methods. MICE is very popular. It is again a shallow learning method. Then FHDI is a very standard and very popular method, recent one as well, and autoencoder based method. So these are done with, these are already this comparison, and what we tried to prove here is that Although autoencoder might be performing better in several cases, but our granular semantics is no worse. It is completely a shallow learning based method. No deep learning has been used, and it is always being trained with a very minimum training data and training data. Still, it is performing almost equally well compared to the other methods. We have then increased the percentage of impurity in the data set, and what we have observed that is that here once we are going to increase the impurity, our granular semantics based method is performing quite well. Even the more we are increasing the impurity in the data set, it is giving some consistent performance even with the increment of impurity, because it might be because we are avoiding, while predicting we are always avoiding the missing entries, and we are assuring while forming the contextual granules. That is why its performance is not getting that much down with increasing with increasing amount of impurity. So this is what, and then we have actually means we have predicted using different 6 different classifiers, starting from logistic regression, then nearest neighbor, decision tree, random forest, gradient boosting, and deep neural network. So here what we could observe is that is we are getting accuracy mostly over 85% always, and it is able to predict the bankruptcy somehow, um, bankruptcy properly. Now, what are the conclusions? That is, proposed granular semantics based missing data imputation method worked well even in comparison with autoencoder. Proposed pipeline for bankruptcy prediction proven to perform with an accuracy more than 85% always. The proposed method could be extended for different other applications with missing data entries, and the part that we are now working with is the reliability aspect of the prediction with different data sets, not only Polish bankruptcy data set, but with different other data sets as well. And granular semantic based method could be extended for data generation as well. That is another aspect we are working on currently. Whether we could design a data generation method, synthetic data generation method, which would be a shallow learning based method, no deep network should be there, and could perform somehow equally or even less, but somehow comparable way, in some comparable way, compared to those deep networks. So this is what is all about my work, and the codes and article is already available, and my contact information is also there. Thanks for listening. Now, please.